Good morning, dear students. So in last lecture just we had discussed about the concept of the capacitor, okay, and we had also derived the formula for the capacitance of the parallel plate capacitor. Okay, in that you had learned about how we had derived the formula for the capacitance of a capacitor, and capacitance depends on which are the factors. Capacitance does not depend on Q and V, it only depends on the medium as well as on the dimension of a capacitor. So today we are going to learn about the combination of capacitor. It is same as that you had learned about the combination of resistance in the junior classes, series combination, parallel combination. In the third chapter also we had done the same thing. In series combination in resistance the current remains the same, or in parallel potential will remains the same. Here in capacitors also the current is due to the flow of charges. So for series combination of capacitor, it is a symbol of capacitor. Capacitor is represented by the two parallel plates, but battery is represented by positive and negative terminal. Take care. Battery के अंदर एक बड़ा और एक छोटा होता है बेटा. Capacitor में both the plates are of equal size. So let C1, C2 and C3 are the three capacitors with capacitance connected in series. Series means only one path is available for the flow of charges. So when you apply the potential difference, the charge on the each capacitor will remains the same. In series, charge on each capacitor remains the same and the potential is different. So for first capacitor the potential is V1, for second it is V2 and for third it is V3. The potential is different but charge will remains the same. Then what is the total potential? V is equal to V1 plus V2 plus V3. What is V? V is equal to, क्योंकि Q is equal to CV होता है, तो V is equal to Q by C. So therefore we can write Q by C1, Q by C2, Q by C3. Take out Q common, so 1 by C1, 1 by C2 plus 1 by C3. Therefore V by Q is become 1 by C1, 1 by C2, 1 by C3. And Q is equal to CV. V by Q is 1 by C. That 1 by C is known as equivalent capacitance of series combination. तो 1 by C is equal to 1 by C1, 1 by C2, 1 by C3. जैसे हमने सीरीज में रेजिस्टेंस का उल्टा हो गया बेटा, यहाँ पे रेजिस्टेंस में R is equal to R1 plus R2 plus R3, पर यहाँ पे कैपेसिटर के लिए 1 by C1, C is equal to 1 by C1, 1 by C2, 1 by C3. When you combine the capacitor in series, their equivalent capacitance decreases and become smaller than the smallest value. रेजिस्टेंस में क्या होता था? ग्रेटर देन ग्रेटेस्ट. उसका उल्टा इन पैरेलल कॉम्बिनेशन द चार्ज ऑन द ईच कैपेसिटर इज डिफरेंट. हियर वी आर हैविंग Q1, Q2, Q3, but the potential will remains the same. Then what you have to take? Total charge. Q is equal to Q1 plus Q2 plus Q3. Q is equal to CV, C1V, C2V plus C3V. So Q by V is equal to C1 plus C2 plus C3. And Q by V is known as equivalent capacitance for parallel combination. तो parallel combination में equivalent capacitance increases and become greater than the greatest value. तो याद रखने वाली बात, in series charge remains same, in parallel potential will remains the same. Potential remains same. In series 1 by C is equal to 1 by C1, 1 by C2, 1 by C3. In parallel C is equal to C1 plus C2 plus C3. Charge same, potential same. Capacitance decreases, capacitance increases. Become smaller than smallest, become greater than greatest. Okay, dear students, we are continuing with the topic. Okay, so in last lecture just we discussed about the combination of the capacitors, जिसमें series and parallel combination that we discussed. So continue with the same. Today just we are going to take the formula for the energy stored in a capacitor, because capacitor is the device which you use to store electric charges as well as electric energy. So how to get the formula, by in which manner it can able to store the electric energy. तो simple सा concept है. We already know about the relation between potential energy and work done in the previous topic. कि charge multiplied by potential is the simple formula for the work done or potential energy. So at any instant of time, let Q be the amount of charge present on a capacitor of capacitance C. where C is the capacitance of a capacitor, Q is the amount of charge. Battery is connected with this. When you charge a capacitor, at that time you are connecting a battery of potential V. So potential is constant. So here we are having capacitor of capacitance C, and Q is the small amount of the charge present on it. So therefore V is equal to Q by C. Okay, and if you want to deposit some charge, you have to do some work. If dq is the amount of the charge which is to be deposited on the capacitor, so what is the formula for work done? Small charge के लिए small work done, dw is equal to charge multiplied by potential difference. So dq is equal to dq, potential difference is V. What is the value of V? So we can write V is equal to Q by C into dq. This is dw. So dw is the small work done, and suppose you want to fill the capacitor with the charge Q, then you have to calculate the total work done. So total work done, okay, total work done कैसे obtain करेंगे? By removing the derivative. Okay, so therefore W is equal to, you have to go for an integration from 0 to Q, Q by C into dq. Okay, तो C तो constant, तो 1 by C बाहर, 0 to Q, Q dq, and we all know that what is the integration of Q dq? Q square by 2, 0 to Q, by substituting. So what is the formula for work done? W is equal to half Q square upon C. So this is the formula for the work done to charge a capacitor. And when the capacitor is fully charged, at that time, taking Q is equal to CV. Q is equal to CV, so we obtain the formula work done is equal to half CV square. Okay, क्योंकि जैसे यहाँ पे CV रखोगे बेटा तो एक CV कैंसिल हो जाएगा, तो वर्क डन का दूसरा फॉर्मूला हाफ CV, और Q is equal to CV रख दोगे, which implies one more formula, that is half Q into V. CV is equal to Q, so half Q into V is also the formula for the work done to charge a capacitor. Again, to charge a capacitor some work is to be done, and that work is stored in the form of potential energy. और यहीं पे formula for the potential energy, U is equal to half CV square, half Q square by C, or half Q into V. So these are the three possible formulas for the potential energy stored in a charged capacitor. Like Q is the amount of the charge present on a capacitor of capacitance C. So Q is equal to CV, or V is equal to Q by C, where V is the potential which is applied across the two plates of a capacitor, which remains constant. Okay, so some work is to be done to deposit dq amount of charge. That work done, dw is equal to charge multiplied by potential, dq into V. V की जगह पे Q by C डाल दो, तो small work done Q by C dq. तो टोटल वर्क डन के लिए यू हैव टू गो फॉर एन इंटीग्रेशन 0 टू Q, Q by C dq. C बार आ गया बेटा, इंटीग्रेशन ऑफ Q dq, Q स्क्वायर बाय 2, लिमिट सब्स्टिट्यूट करो तो वर्क डन इज इक्वल टू हाफ Q स्क्वायर बाय C, Q इज इक्वल टू CV, तो W इज इक्वल टू हाफ CV स्क्वायर, और W इज इक्वल टू हाफ Q into V, and this work done is stored in the form of potential energy. So we can also write U is equal to half CV square, half Q by C, and half Q into V. Okay, I think you can able to understand the formula, and then we are going to discuss about the concept of energy density stored in a charged capacitor. Okay dear, as we told that next topic is our energy density in terms of the electric field. So what do you mean by the word energy density? Energy density is the potential energy stored between the two plates of capacitor per unit volume. So rho E is the representation of energy density, potential energy per unit volume. So what is the formula for potential energy stored in a charged capacitor? That is half CV square. Okay, and V is equal to area multiplied by distance, that is the volume. Okay, this V for here, it is not a potential difference, it is the volume, and V here chota v, that is for potential, and you can also take V dash. Okay, so therefore U is equal to half, and what is the capacitance of a parallel plate? Epsilon 0 A by D, and potential difference between the two plates, that is E multiplied by D. Okay, so simplify this, so half epsilon 0 A by D into E square D square. तो ये कौन सा टर्म कैंसिल हो गया बेटा, यहां से देखो डी डी कैंसिल. नाउ वी कैन ऑल्सो राइट हाफ इंटू एप्सिलॉन 0 ई स्क्वायर, फिर एरिया मल्टीप्लाई बाय डिस्टेंस, दिस ए एंड 1d, और एरिया मल्टीप्लाई बाय डिस्टेंस इज द वॉल्यूम, AD is the volume. So therefore we can write U by V is equal to, this is the volume, become half epsilon 0 E square, and U by V is rho, so rho E energy density becomes half epsilon 0 E square. What is the unit of energy density? Unit of rho E energy is joule and volume is meter cube, and we are going to derive the same relation in terms of magnetic field in chapter number 6. So again, potential energy per unit volume is known as energy density. U by V, U is equal to half CV square, volume, that is V dash, is equal to area multiplied by distance. Okay, and C for the capacitance of a parallel plate capacitor, epsilon 0 A by D into V is the potential difference, so V is equal to ED. तो यहाँ पे सिंप्लीफाई करो बेटा, यहाँ से dd कैंसल, तो epsilon 0 E square, A into D is to be taken as V dash, that is the volume, तो U by V dash is equal to half epsilon 0 E square, तो rho E is equal to half epsilon 0 E square, and unit of energy density is joule per meter cube. Okay, thank you.